Good afternoon, and welcome to this EHS Today New Equipment Digest and Machine Design webcast entitled General Machine Safeguarding, Non-Separating Guarding, sponsored by Schmersal USA. Hi everyone, I'm Bob King, editor of New Equipment Digest, and it's great to have you with us today. Before we begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, please press the Help button on your player console to receive assistance. We welcome your questions during today's event. Simply type your question into the box on your screen, then hit the Submit button. We'll answer as many questions as possible during the Q&A session that will follow the main presentation. Please feel free to send in your questions at any time. Also, if at any time you have audio difficulties or trouble advancing the slides, simply hit your F5 key to refresh your webcast console. Please also be aware that today's sessions are being recorded and will be available on the EHS Today, Machine Design, and New Equipment Digest websites within the next week. You will be notified by email when the archive is available. Now, let me introduce today's speaker, Michael DeRozier, Schmersal Engineering Services Manager. Mike is a TÜV certified functional safety engineer for machinery. His 19 years of experience includes controls engineering to design, build, and integrate full machine control systems. Mike's safety experience led him to help corporations develop corporate safety standards, perform machine safeguarding risk assessments, machine safety training and design, as well as implementation of safety systems for all aspects of machinery, including electrical, electronic, pneumatic, hydraulic, and mechanical. Mike, the floor is yours.
Thank you, Bob. Hello, everybody. Appreciate your time today. Glad you can all make it to learn a little bit more about non-separating guarding and hopefully take a little of the mystery out of it for you. Non-separating guarding is another word for presence sensing type of technology. In previous sessions, we have done a breakdown of separating and non-separating guarding. Last fall, we did a webinar on separating guarding, where we've talked about different types of fixed and movable guards and the devices you need for those type of guarding and guarding aspects on the machine. For those of you that wish to either view that again or have not viewed it and would like to view that, that recording is still online. The link will be sent in a follow-up email. As well as you can go to our website at schmersalusa.com or schmersalcanada.com and get to the link from there to view our separating guarding webinar. So this spring we thought it would be good to talk a little bit more about guarding technology and look at the non-separating guarding. Non-separating guarding is typically broken into 5 different areas, with the localized emergency off or emergency stop, tactile type of devices such as safety mats and edges, electrosensitive such as single light beams or light curtains and scanners, two-hand control, and enabling devices. And we're going to go through each one of those topics today. The first one I want to talk about is emergency stop, and sometimes this emergency stop button does create a lot of questions on whether emergency stops are considered safety devices, are they primary devices, and one of the misconceptions that we see out there is people think that emergency stops are the primary safety device on a machine because every machine requires e-stops. Reality is emergency stop devices are secondary. And what we mean by secondary is something in your primary guarding has catastrophically failed. There's something gone wrong in the machine that somebody needs to be able to reach and hit an emergency stop or an emergency off type of push button on a machine. There's certain criteria when you look at the various different standards out there on what an e-stop really should be. E-stop, as you can read there, could be either a red mushroom or palm style, positive brake with the yellow background, and that's one of the things that often gets missed. A lot of older machines, for example, may have red mushroom switches, but not necessarily the red background, and also may not be wired in properly. into the machine to act as an emergency stop or an emergency off type of device. Another one is it can be blank or local verbiage, and what we mean by that, a lot of people think that the word e-stop has to be on that yellow background, and that's not necessarily true. It's the color combination of the red on yellow that designates that as an emergency stop or an emergency off type of device. The way we talk about it with positive self-latching and positive brake, there's certain construction differences in design guidelines such as ISO 13850 for the construction of an emergency stop device. What we mean by positive self-latching and positive brake is a mechanical linkage that actually breaks the contact, the normally closed contacts open to create an open circuit upon hitting that e-stop. Under the design criteria, there's certain forces that emergency stop has to be able to take because of it being a secondary reactionary function. People are slamming at the e-stop. They are hitting it. It's not just a simple push of a button. They are smacking at that e-stop. And the construction of that e-stop in the contact carrier has to withstand that without breaking apart. The positive self-latching is it basically has two distinct positions. Those two positions being a push-pull or twist-release, it's either out or it's in. There's no in-between with it. One of the common areas that you see, especially on older machines, that they have buttons labeled as e-stops, you may see spring-loaded type of e-stops, momentary push buttons. Those are not considered emergency stop devices. There's two typical failures of those devices. Going over again that it's reactionary, people are smacking at it. Two failures that can occur is, one, they may not be able to hit that e-stop all the way in, or they don't hit that e-stop all the way in, and it doesn't actually break the contacts. That's where the positive self-latching comes into place, that it is a true detented position and locks in the off condition to ensure you're breaking the contacts open. The other aspect of a momentary push button is when you're smacking at it, you're smacking and coming off of it. The internal circuitry behind the scenes may not have enough time to actually collapse the field and initiate a stop on the machine. So there's some shortcomings with older styles, mushroom or spring-loaded style switches, where the e-stops that you should be using today would be that push-pull, twist-release, positive self-latching, but also be approved to a certain safety standard like ISO 13850. Just because it's a push-pull doesn't mean it's rated for an emergency stop device, and you would just refer to the manufacturer that you're purchasing your e-stops from to verify that. Another type of emergency stop is an emergency rope pull. There are rope pulls that used to be used out there that allow slack in the wire. They are great triggering devices. They're not emergency stop devices. A proper emergency rope pull will have to detect cable breakage as well as cable pull. Same design standards such as ISO 13850, but the emergency rope pull, you would actually have a rope that strings along the machine. Probably the most common areas you see are conveyor type of systems, where instead of having a number of push buttons all across the conveyor because of where of operators working, you would have one emergency pull switch. Same criteria applies where it is a self-latching device. The emergency rope pull has to be mechanically reset in order to turn the contacts back on to allow the machine to re-engage again. So an emergency rope pull with your red cable, run through that. You can have e-stop devices, tension windows. Different manufacturers have different features, availability, and accessories with it. But the main aspect is it has to detect cable pull as well as cable break. I added this slide as well to talk about stop categories. Many of you may be familiar with control categories, B, 1, 2, 3, and 4. I'd like to point out that we don't want to confuse stop categories with control categories because they're two different aspects. The stop categories really relate to how the machine operates under an emergency stop condition. You have Category 0 and Category 1. A Category 0 stop, as soon as you hit that E-stop button, you instantly remove all the hazardous energy from the machine. Now, I make that nomenclature, it's hazardous energy. Doesn't mean you have to kill the entire power to the entire machine. You have to determine by risk assessment what is the hazardous energy and remove that hazardous energy, and you may need to leave power to things like a PLC, for example, or sensors to know what went wrong in that machine. A Category 1 is following the same concept. However, in certain cases, in certain machines, depending on the components and the nature of the machine, you may need a Category 1 stop. A Category 1 is a controlled stop, then removal of the hazardous energy. What that means is you actually initiate a stop command with your devices. Probably one of the most common ones would be drives, whether they're variable frequency drives, inverters, servo motor drives. You cannot just simply remove power from that drive or separate the motor from the drive. Doing that may cause loss of control, such as freewheeling, which can create a hazardous condition. Or the other aspect is you can damage equipment, which you don't want to do with a safety device either. So you may need to initiate a Category 1 stop, which in the case of a Category 1 stop, you would send that stop command, allow the machine to stop safely, and follow it up with removal of the hazardous energy to ensure that you are in a safe condition at that point. The next type of non-separating guarding has to deal with tactile devices. The tactile devices are safety mats, edges, and bumpers. It requires pressure to be applied to one of those devices to trigger it. The first one we will talk about is the safety mats. Safety mats are probably no different in concept of what everybody's used to when you walk into a grocery store, for example. You step on that black mat with the trim on the ground, which initiates a door opening. In that particular case, it's not a safety consideration. You're triggering it by opening up the door. In order to use this as a safety device, there's a couple design concepts that you put into it. There is certain standards such as ISO 13856 Part 1 for safety mats on the construction of mat, which relates to the design and the forces needed to trigger that mat. The mat has to have some sort of trim to it to lag it down to the ground or to the floor or to the base of the machine. A mat has to be secured. You cannot just simply slide the mat out of the way. The other consideration you can see in that right middle picture, kind of a breakaway of a mat concept, where this is actually showing a two-plate concept, but both plates have two wires on them. There's two wires on the top and two wires on the bottom. The reason why you do that is you have a dedicated safety mat controller that it's actually looking for cable break. So it's looking for open circuits as well as short circuits in the system, and the mat plates shorting out together. Why that's important is we're trying to detect presence inside of an area or in front of an area, for example. Robot cells. Inside of a robot cell, if somebody can be stepping inside that robot and the robot can start up, that becomes a problem. So there are certain things that you can do. Safety mats are one of them. If somebody is standing inside the cell on top of a mat, the mat controller detects that and prevents the robot from coming out of the interlock mode because of detecting presence of a person being inside that cell. It can also be used around machines. The big thing with mats, though, is you have to take in consideration the size of the mat that you need. As we move on with the different devices, toward the end, one of the things we are going to talk about is minimum safe distance. Minimum safe distance has a very critical role in making sure these types of devices are applied properly. These devices are not like a hard guard, where a hard guard, based off of design, physically stops you from entering into a cell. or it stops ejection of material. Things such as mats or light curtains do not stop that from happening. You can still enter the cell, step into the machine, go through that invisible wall. You need to apply the proper minimum safety distance, and mats are no different. There are different formulas, and we'll go through some of those a little bit later on. But here you can see the trim lagging it down to the ground and the top and bottom plate concept. Well, you do need that dedicated mat controller that's rated for safety mats to ensure that it's a proper safety device and connect it properly. The next group, I put together the edges and the bumpers. There's very different sizes and flavors. Larger foam type of bumpers that you see on automated trucks, for example, bump switches, or strips such as black strips, and there's a couple different concepts. One is a two-plate concept that has a terminating resistor with a dedicated controller. The other could be a fiber optic like you see pictured here. Some could be positive break sections that actually break a wire open inside the length of the edge. So there's a couple different types based off of the manufacturer and what they're making and producing and selling into the market. But at the end of the day, the concepts are the same. The idea is when you press up against the bumper, it'll initiate a stop on a machine or a door depending on how that's being used. Some common examples would be automated doors. You see on the bottom of probably the best example you probably see is on garage doors. Some warehouse-style garage doors have black strips on the bottom of them, and they're to detect any obstruction of that door closing because it's an automated door. It hits that black strip on the bottom, the door either stops or automatically reverses. The same concept is applied to machine guarding. Sometimes you try to make it more ergonomically friendly for an operator so they're not constantly opening and closing in doors. So you power the doors. You make them automatic, whether it's motor-driven, pneumatic, hydraulic-driven. It doesn't matter. It's an automatic door that you're making it easier on the production operator. However, what can potentially happen is that automatic door will have force behind it. And if somebody gets their hand, arms, legs, head caught between the door and the frame, it's potential to cause severe injury up to fatality. So having something like the edges on the edge of the door that it can detect, stop, and possibly reverse before any serious harm would come to somebody trying to step through that particular area. The edges and the bumpers are just like the mats. There's dedicated controllers that you have to pair up with them to ensure they are the proper safety device. The next concept is the electrosensitive type of devices. The first one are basically the single beam devices. In all cases, this is a transmitter-receiver pair. And although they may look like standard type of retroreflective, or I should say through beam type of sensors, it's a transmitter and receiver, but it's those devices either with the onboard built-in controllers that are approved or the external controllers that they are wired up to that makes them safety devices. Because even though it's a single beam concept, it's not just a beam that turns on and off when you break it. It actually may do a pulsing concept where it's doing a continuous self-diagnostic check on those beams to make sure they are working properly with the controller and approved as a safety devices. Now I list here that you can have Type 2 or Type 4 devices. And what we've seen over the last couple of years is the Type 2 really hasn't been out as much, or a lot of newer designs are not incorporating Type 2 just for the simple cost factor has come so much closer together. Type 4 is a safer device than a Type 2. It's rated for a higher safety level. So the more common devices in today's world are the Type 4 devices. But it does come back to the risk assessment and what is the proper device that you really need on the system. But the concept behind a single beam or a grid type of device is that you're looking for whole body detection. It's not made for finger or hand protection. It's basically a body passing through it. So you can see by the single beam or in that grid concept there, you can stick your hands and arms right through those two beams up to your shoulder, but that's when your body breaks those beams. So you're going to have the proper safety distance based off of body detection. It's not made for anything more than that, trying to get into an area. The next ones are the light curtains themselves, AOPDs, which are active optoelectronic protective devices. Still a transmitter-receiver type of pair, but there's an array of photoelectrics, infrared beams that are inside that emitter and receiver. And the way those work, even though you always see representation of red straight lines going all the way across them, reality is they are pulsing on and off at different time intervals to ensure that the devices are working properly. You can have a 2-box or a 3-box system, and what that means is a 2-box means all the controls are built into the 2 sticks, the transmitter and receiver. You can have a 3-box where you have a transmitter and receiver which houses the optics, but then the controls are built into a 3rd-box controller. These are usually purely electronic devices. They give you solid-state outputs, and you need the appropriate controller to handle them. But they come in different resolutions. The most common resolutions and what you see in the standards are 14, 30, 40, and 70, which relates to finger, hand, arm, and leg protection. The concept is you stick your hand through it, it's an invisible wall. You don't see physical red light going from one end to the other. It's an invisible wall. Instead of having a physical guard there, you break between that transmitter and receiver, it initiates the stop on the machine. So you can have different features related to those, and we'll talk about some of the features related to the electrosensitive products as well. The last one in this group is a scanner, a laser scanner. With the laser scanner, these are listed as a Type 3 device. They basically work off a time-of-flight concept where they send out a beam and look for that beam to bounce back and measure that distance based off of there and if there's any obstructions with it. So the laser scanners go through and you can actually sculpt the field. Even though they may have a radius of 180 degrees or 270 degrees based off of the scanner manufacturer and the device type, you can actually sculpt a field within the specifications of the manufacturer of that device and make a custom area based off of that laser field. It will not see behind objects. It's only up to the objects, but it basically puts out, in essence, an invisible floor plan. If you think of a safety mat being on the floor, sometimes safety mats may take a lot of abuse, such as forklift traffic, that they're not going to withstand the constant demand of the rollers or the wheels of the forklift, where a laser scanner can accomplish the same thing, but not have the mechanical wear, and the forks can go right through it without causing problems with the scanner. You also see these on AGVs, automated guided vehicles, where if anybody's ever experienced walking in front of those, they have the warning zone in which the AGV will slow down when it gets a little too close, but then when you are too close in the actual detection field, it initiates a stop of the AGV until that field has been cleared again. So a couple different applications for the scanners as well. Some special functions related to electrosensitive devices, being the single beams, light curtains, scanners. You can actually have things like fixed blanking, floating, muting, cyclic, EDM, and interlock. What these really mean is, I'll go through them one by one. Fixed blanking would be an object that's sticking through the device, such as a permanent tool holder on a press, for example. It sticks through the light curtain, and you have to teach the light curtain that that object is supposed to be there. That's called fixed blanking. Floating, if anybody's ever experienced metal fabrication where you have steel coming off of a roll, or it might be fabric coming off a roll in the textile industry. You're not always guaranteed that that material coming off the roll entering in the machine will always be at the same spot. You have a feed system and a tensioning system, and you may have some accumulation up and down depending on the demand. So you don't want the machine pulling against the entire weight of the roll. The roll is power fed, but there may be a min and max to where that roll is, so it keeps feeding material into the machine without putting too much tension on it. Well, in those cases, you're not going to guarantee that the material will always be in the same spot, but you have to guard it to keep people from being able to get into the entrance or the exit side of a machine. What you do there is you can potentially float beams. Typically, it's one or two beam floating. It depends on the manufacturer and the options that they have, but you can float one or two beams. So if we had something such as a 30 millimeter resolution light curtain, what the resolution means when we were talking about finger, hand, arm, and leg detection is what the minimum object size and you're guaranteed to trip the light curtains versus being between beams. So a 30 millimeter resolution means that anything 30 millimeters or larger will be guaranteed to trip the light curtain through any section of the light curtain itself. But it's considered hand protection versus finger because you can take your fingers and actually enter between two beams and penetrate so far to guarantee tripping one of the beams to initiate a stop on the machine. So if you think of a coil of material coming through, it's thin enough, but it may be enough to trip one of the beams that you have to float, which means you allow the light curtain to ignore one beam being broken by the material, and anywhere in the light curtain field, aside from the first beam on most manufacturers being the sync beam, you can allow the material to run through the light curtain without tripping it and causing a lot of false trips on the machine. But if you were to stick your hand in there and block a second beam under the material, then the light curtain will detect that and initiate that stop that you needed to offer that personnel protection. Muting. You see this a lot on palletizers. You have robots or just palletizing type of machines that are stacking boxes onto a skid. That skid may enter and exit out things like shrink wrappers, that you wrap that skid up automatically. The issue is the pallets have to be able to go into a machine, and they have to be able to come out of a machine automatically. It's not a manual operation. But when they come in and out, if there was doors that opened and closed, people can walk in, behind, through. So a lot of times light curtains or scanners may be installed to offer that protection to keep it open to allow the pallets to go in and out. However, there's some special functions on using additional sensors to tell the light curtain when a pallet is coming through and when it's not. And we'll talk a little bit more about that as well in some more details. Cyclic operation, which in the U.S. and some of the standards you see as PSDI, Presence Sensing Device Initiation. A lot of words there, but what it really means is this is the only time that you see in any of the standards that you are allowed to use a safety device to trigger a cycle on a machine, to actually start an operation. And we'll talk about that function in a little bit more detail as well. EDM, because most light curtains have solid-state outputs, you may need dry contacts to interface with your machine. So in EDM, because the contacts or the mechanically linked relays that you're connecting to the light curtain to transition the solid state to dry contacts become part of that safety device, they have to monitor whether those relays, the mechanically linked relays or mechanically linked contactors, are functioning properly so they're fed back in. That's the external device monitoring. The last one is the interlock function, which you can set up a light curtain to be an automatic, start on power up, or a restart where every time it's broken you have to hit a restart. Again, it comes back to your risk assessment and what the function is on the machine and what the proper way to implement that device is on your machine. Here's an example of fixed blanking, because sometimes it's a little hard to visualize. The top picture is showing an example of a tool sticking out through a machine. It might be like a tabletop or a platform or a tool rest. It's blocking 4 beams and a light curtain, so you actually train those 4 beams to ignore the obstruction or actually know that it needs to be obstructed. If the object comes out, one of 2 things happen. Either the light curtain shuts down or those beams become active right away. It depends on the style and the manufacturer. However, it's looking for the obstruction, so when you start up and it doesn't see it, it sees it as a problem and won't allow it to start because it knows that there's a big gap that somebody can reach through without actually stopping the machine. The tool actually becomes part of your guarding because you cannot reach on the sides to get into the machine. So what do you do in cases where the tool width is smaller than the width of the transmitter and receiver? That may or may not be a problem. You have to have additional means, such as additional guards that may have to go in place so people cannot reach through the sides to get into a hazard point. You really have to look at your application and make sure you apply these properly. Muting. Here are some pictures you can see of a 2 and 4 sensor setup. They can be unidirectional, bidirectional. You can set it up different ways. Again, look to your manufacturer's specifications and installation instructions to look at the configuration. But here are some of the considerations you have to detect. Must only detect material, not people. The whole concept of using 2 and 4 sensors is to detect direction, whether it's unidirection, and to have some redundancy in there. But you don't want to set up the sensors where somebody can just walk right through, block both those beams, and mute the light curtain and walk into the machine. It becomes an ineffective safety device, and that's not installed properly. You have distance requirements, such as the gap between the object and the open area must be less than 200 millimeters. What that means is, you can see on the bottom right, when a pallet comes out through the machine, you have a distance between the transmitter and the pallet and then the receiver and the pallet. That should not be any more than 200 millimeters. The reason for that is 200 millimeters, which is just about 8 inches, people cannot sneak necessarily, or I should say easily, between the pallet and the light curtain while it's in a muted state to get into the machine while the machine is running. If that gap was bigger, it might be potentially easier for somebody to just slip right in there and not had to really try to create that mute function and get into a hazardous situation. There's also a minimum space requirement and maximum space in the distance between mute sensors. And the concept is you need them to be greater than 250 millimeters in spacing because you don't want somebody to be able to walk up on the conveyor and have just your legs and your pants to trip those sensors and cause that sequence of that muting function to begin with. There may be some other functions and other features, such as muting lamp. You have to have a muting lamp, for example, so that lamp has to be on. So your muting controller, whether it's built into the light curtain or it's a separate controller, detects that that lamp's working. So you actually have a lamp that comes on to let people know that that's in a muted state at that given time to give additional indication. The cyclic operation, one of the best things, there's a little video clip, but you cannot run the video clip easily over the web, so I'll try to explain this the best I can. Typically, you can do 1 or 2 cycle. If you think of a press as probably the most common application, you would see something like this, a manually fed power press, whether it's a hydraulic press or a pneumatic press, something like that, where you're manually feeding parts and it could be taken away automatically and you're just constantly feeding parts, or you can be feeding and unloading. That's an example of a single or a dual trip. So you go in there, unload the part, which is one break of the light curtain, grab a new part, go in, you break it a second time. Now upon that second break, as soon as you clear the light curtain, you initiate a start cycle of that press to perform its operation. The effectiveness is going to be on the installation, but really the whole concept and the ideal situation for something like this really helps operators out to be more productive and not have to constantly hit a restart or a reset button every single time they have to go into the press. PSDI or cyclic operation does have certain limitations of use. You can only use type 4 devices. If there's multiples, you can only use one device on the machine to do it. It's supposed to be for a manually fed machine. It's got to be repetitive, a short cycle, only one operator. That's key. You can't have two operators that feed and not feed with it, or unloading. Reinitiation of the machine cycle must be time limited. So even if an operator gets distracted, there's a timer built into it that says, okay, 30 seconds has elapsed. We should not be triggering this light curtain to start the machine. Something's wrong. It's not in the normal routine process. You have to hit a reset button. So there's some certain design considerations related around that. The next one is two-hand control. With two-hand control, they can be mechanical push buttons or non-contact type of switches that are rated for two-hand control. Whether they're in a station or they're in their own housing, there is a special two-hand controller that goes with them. It has to be anti-tie-down and time-limited, meaning that both actuations of the push button, the concept is to tie down both hands. You're taking both hands and binding them down for the operation of the machine to ensure people are present there, not inside the machine during that cycle. You have to trigger them within 500 milliseconds of one another. And the anti-tie-down means you can't tape one button down and just turn it into a one-button operation or a single-hand operation. Those criteria are listed in ISO 13851, which gives you a real good generalization on how two-hand controls really need to be worked based off of your risk assessment and your safety categories. It's really ideal to ensure these things are installed properly and at the proper distance. The last device we're going to talk about is the enabling device. Based off of the EN 60204 standard, you can have 2 or 3 position devices. Personally, I would like to recommend 3 position over 2 because it requires the triggering of the switch, and if you squeeze too hard or you let go, either one will initiate a stop on the machine. Proper terminology you see for enabling devices is a live person switch. The idea in a 3-position switch is you squeeze the trigger. It might be a special function such as a slow speed or a jog or a setup mode that certain machines have to require without the guard in place. It's ideally to always guard everything to the best possible way you can do it. Certain machines just require interfacing even in a limited speed motion to do a setup, for example, to get the machine running properly. An enabling device will help with that. It's not a end-all, be-all because you do have some risk associated with it. It's just not as bad, and it comes back to the installation. But if something happens where a person panics, typically in an emergency situation, people lose their fine motor skills. Their coarse motor skills still happen. So what's going to happen is they tense up, their muscles squeeze. They squeeze that trigger, initiating the stop. The other thing that can happen is they panic. And when they panic, they also may just drop everything in their hand. Either actuation on the 3-position switch will help initiate that stop cycle on the machine. You have different flavors where you can get e-stops and additional push buttons and jog buttons on the devices depending on the manufacturer. You also want to make sure that this is installed to the appropriate category. So whether it's a Category 1 or Category 3 on the controls, you install that properly. With any of these devices, however, you have to take certain things in consideration. We're going to talk real briefly here about the ISO 13855, which is the safety distance formula. Motion has to stop any time within the machine cycle. Things like full revolution presses where there's a little dog ear, presence sensing devices are not the proper application for this. You have to stop anywhere within your cycle. As soon as you initiate it, you have to initiate that stop. Some machines may have inconsistent stop times. If you stop in 100 milliseconds one time and then 2 seconds another time, it's going to be too hard to apply those devices. How you connect it into your circuit. What other environmental things can happen. Laser scanners, for example, a lot of smoke or a lot of weld slag can actually cause interference and cause a lot of trips. It may be a great device, but it may not be the proper application. Same thing with light curtains. No protection against flying objects. These things are not hard guards. They're not physically stopping you or an object coming out. So if you apply a light curtain, if you have the risk on that machine of flying objects or chips coming out, even though the light curtain may be working properly, if it can hurt you, that's a problem. It's not a proper application for a presence sensing device. So when we look at the safe distance formula, it seems like a real simple formula. You take your hand speed multiplied by your total stop time in the machine and any additional factors. ISO 13855 gives you a whole lot more detail, but applying this formula is a lot different than using safety distance formulas like we talked about in the separating guarding based off opening size. When you had an opening size that was a half-inch open, you had to be so far away from the hazard. You cannot take those same charts and apply to a presence sensing device. A hard guard physically stops you based off of that opening size. A presence sensing device or non-separating type of guard does not do that. You're continuing to go in the machine. So there's time factors associated with it. So you have to look at the proper timing. The considerations that you take into effect is your resolution, your approach speed, direction, as well as your reaching capabilities. Here you can see a couple pictures of where minimum safe distance is, where is the hazard point, where should the device be mounted. Is there reflective surfaces that can cause beam bounce on a light curtain or a single beam device, for example. But sometimes people think that one formula fits all. Reality is, when you look at some of the different formulas within ISO 13855, there's different formulas for different devices. So whether you're using a light curtain or a two-hand control or a laser scanner, you can see the first couple of formulas are typically related around light curtains or beam devices. The formula under number 6 there has to do with laser scanners because it's accommodating the height of the scanner, how far it is off the floor. Other things such as formula 4 and 5 may deal with safety mats and how far you can reach over, or light grids, for example, reaching through. The last one there is usually related around two-hand control. What is the distance that the two-hand control station needs to be away from the hazard point? So applying the proper formula to apply the device properly is really key on making sure you have an effective safeguard. Here you can see a picture of a standard guard on the top left with 2 front doors. Many times the doors become cumbersome or may not be as ergonomically friendly. There may not be any issues with ejection of parts. So people start looking at the machine, you know what, let's make it easier, let's be more productive, let's put light curtains on this machine. One of the most common mistakes that they make is just taking the doors off and applying the light curtain to the same exact frame where the doors were, thinking that they are good as a proper position for the light curtains because it's convenient, has a really good frame right there to mount to. Reality is this is incorrect because you did not take into account the safety distance needed based off of the stop time and the reaction of the machine. So reality is your light curtains, based off of your stop time, may or may not need to be further out. So you may need to build that guard out a little bit based off of the actual stop time of the machine. So it's really important to ensure that you're using those minimum safe distance formulas to apply those presence sensing devices. It's like everything we talked about with pros and cons on interlock switches, using the different types, what are the advantages and disadvantages. They all have their place. Non-separating guarding devices have their place as well. There are applications that these make the most sense make you the most productive, and provide you the best safety possible. There's other applications that a hard guard makes more sense to be applied properly. So there's a lot of different areas and different things you can do. You just want to make sure that you know the limitations of non-separating guarding and what makes sense for your application. So at that point, Bob, I'd like to just open it back up to questions now.
Thank you, Mike. And we have a lot of great questions, so we're going to jump right in. And while Mike is answering your questions, please take a moment to answer the feedback form that will appear on your screen. If you have pop-up blocker technology, we ask that you disable it so that you can receive the form. So, Mike, our first question is, what is the distance for two hand-control palm buttons from each other?
When you look at the standard ISO 13851, there's no specific distance given that how far apart palm buttons really need to be. They list a couple different criteria. It comes back to installation and design. You don't want to make it easy to trigger those devices, such as using one hand and a forearm, for example. So it might be done by distance, where the average operator that a person has, the distance needs to be greater than that operator, so you can't trigger it with one arm and one forehand, such as just normal push buttons. Adding the proper shrouds to go around it. So they need to be positioned in a way where it's not easy to defeat with one hand and make it a one-hand operation.
All righty, our next question. When the light curtain is broken on a hydraulic or pneumatic press, should the ram stop or return home?
It can do either one. It depends on the risk assessment and the hazards. Normally, you may be a stop command, but when you look at your risk assessment, if there's no hazard of the ram opening up, that may, based off of your risk assessment, may be the ideal situation because you don't want additional pressure going on there that you can actually reverse the ram. Some presses have the hazard in both the close and the open, so in those cases you want to stop the ram exactly where it's at to prevent any motion. You see that a lot when people are trying to adjust parts. They stick the part in there and they see something when the ram's moving and they quickly go in there to try to fix it before it stopped, not realizing it. So whether it stops or goes back up, it really depends on your risk assessment and what hazards are posed if you create motion going the opening direction.
All right, now next question. Can muting be programmed for more than one suspension in a given cycle?
Read that to me one more time, please, Bob.
All righty, Mike. Can muting be programmed for more than one suspension in a given cycle?
If I'm understanding the question correctly, and please retype the question if I'm not answering this to what the question is, your muting can be, depending on the manufacturer and the options, you can have an unlimited mute. You can also have a time-limited mute where you're time limiting for that particular object. And what we mean by time limited is even if something sticks and jams in that conveyor belt coming through, the light curtain would time out because it knows it's supposed to be clear at that point in time and something has gone wrong. If you have continuous boxes coming out that they're back to back to back, such as the exit side of a conveyor off of a machine, you may need continuous mute, but then it's active when there's a break in the boxes. It really depends on the application and the devices that are selected for it.
All righty, and next, throughout the presentation, you reference ISO, EN, NFPA, IEC, etc., consensus standards. Are any of these standards incorporated directly or by reference in OSHA regulations?
They are not. They are not incorporated into the incorporation of reference into OSHA. The key when we look at the U.S. with OSHA, OSHA is our governing body, and no consensus standard will override an existing OSHA standard. One of the things OSHA does recognize is that they know that their standards are not nearly as up-to-date as what the current industry consensus standards are in current technology. So you will see them reference that you should look at industry consensus standards such as ANSI and ISO, as they will be more up-to-date, but ensure that if there is a equivalent OSHA standard in place, that if an industry consensus standard tries to tell you to take it to a lower level than what the existing OSHA standard is, that's not going to be accepted. If it's equal or higher, there's not a problem with doing that because you're providing that higher protection based off of that ISO standard. So as far as OSHA is concerned, they're not going to flag you for not following a specific ISO standard because they're not incorporated in the reference. They may, if they know of something and are aware of it and trained on that and they're looking for it, may cite you more of the general duty clause as a possibility. But reality is, and I hate to say this, it's really more of the litigation that comes into effect when you're dealing with industry consensus standards. Because if somebody gets hurt and they can easily prove that you've known of better principles and practices such as ISO or ANSI standards and you did not follow that, that's hard to defend in a court of law. It's unfortunate that we're at that point, but reality is that's what it can be. And you really want to try to follow industry consensus standards, forgetting about OSHA and forgetting about litigation. There's a lot of work that went into these from both a manufacturing side as well as the equipment side, the builder side, and end customer side that have gone into these standards, whether they're type A, B, or C standards specific to a machine or a group, that they've really learned a lot and what the proper protection is for a machine to really help the machine function properly with providing the best safety you can.
Very good. And Mike, our next question, can PLC outputs be used for muting?
PLC outputs cannot be used for muting. And the reason for that is there's standard PLCs, like any other devices, can fail to an unsafe condition. And I know it's a little hard to see because you're using standard sensors, but they're discrete sensors that are basically isolated and only running off of or running directly to the light curtain. They're not being fed from a PLC and looking for logic. The light curtain has a logic in there, or the mute module has a light curtain in there that's actually looking for those discrete sensors.
All right. And our next question, on an e-stop circuit, is a special self-checking relay needed? What are these relays called?
Special self-checking, there's nothing that I know of that requires a special self-checking. I'm going to default that back to your risk analysis to determine what safety level you really need. Because if you look at your e-stop, and you'll see this a lot with the current control standard of ISO 13849, you identify the functions, your safety functions on the machine. The guard door interlock would be a function. An emergency stop would be a function. When you look at the e-stop, you look at the decision tree of severity, frequency, and possibility of avoidance to determine what performance level you need and ultimately decide which category is right for that particular setup. So if the e-stop really only needs to be a Category 1, which is a single-channel system, it doesn't require a special self-checking relay. There's nothing dedicated that is going to need that. If it requires a Category 3, you're using a safety relay that just the safety relay is rated for emergency stops or guard door interlocks or light curtains, that particular case, and whatever additional features you need, such as cross-short monitoring.
Okay, thank you, Mike. Our next question, is the yellow background a requirement globally?
Yes, there's in a lot of different standards. You see it in the ISO standards, EN 60204, and NFPA 79. And many of the ANSI standards. So a lot of the global standards are calling out the red on yellow.
All right, another question. What is your opinion on collars around e-stops?
That's a loaded question. In most machine type environments, my opinion is you do not use collars at all. If you're using collars, many times the reason I see collars installed is because they're tired of false trips on a machine, people leaning up against the e-stop. All the collar did was create a Band-Aid to prevent you from false tripping the machine. Reality is, because you're in a panic situation, you have to be able to slap at that e-stop button. Once you put a collar around it, all you're doing is hurting your hand and not necessarily triggering the e-stop device. Normally, the best thing you can do is actually relocate the e-stop, move it up, turn it 90 degrees so it's a top-down type of hit versus a side hit, and you eliminate your false trips on the machine. In other applications, and this is where I say it becomes a loaded question, if you look at your risk assessment, the things that you have to do on an emergency stop, and I'm going to probably quote more like a chemical type of industry, hitting an e-stop may actually dump chemicals, which can create an even greater hazard than what you were trying to do. So there you may justify the use of collars because you do not want an accidental trip, even at a slam, where a chemical can be released and create a more hazardous condition, environmental condition. You want to be real sure that you're hitting at the stop, so collars are a little bit more accepted. But in the typical machinery world, presses, packaging machines, pharmaceutical, food and beverage, that's usually not the case. It's usually the collars are installed to prevent false trips versus changing the application to make it effective and not inhibit it.
Great, Mike. Our next question is a two-part. Does a light curtain failure when in use automatically stop the machinery? And the second part of that is there an inspection standard for light curtains?
All right, the first part, does a light curtain stop upon a failure? One of the differences is in Type 2 and Type 4 light curtains is Type 2 and Type 4 generally relates to a control category 2 or control category 4. A Type 4 light curtain, upon any fault, because of its internal diagnostics, any fault to achieve that Type 4 rating will shut its safety outputs down. They do all their own cross-short monitoring. A Type 2 may or may not always fail to an off condition. Depends on the failure that's going through, but that also relates more to the risk assessment on the use of the Type 2 light curtain. And that's also a reason why many times Type 4 light curtains are more preferred and the cost being close to the same as well. The second part of that question, as far as the checks, you would have to go to the manufacturer's installation instructions. From what I know, most manufacturers, if not all of them, do have a check procedure, whether it's using a test rod and how often you should do it. It's usually listed in the manufacturer's recommendations.
All right, another question. Is it required to update emergency stops, such as a rope pull, if the current rope pull doesn't initiate if the cable breaks?
That one, I want to say, is a little bit in a gray area. When you look at ANSI standards, for example, in the U.S., typically in any ANSI standard, when you look at the beginning section, when to apply this standard, it'll give you a timeline. For any new equipment, it's immediate. For any existing equipment, I've seen them from 24 to 36 months of implementation. They should be brought up to date. Should you update the machine? Basically, it comes down to knowing that you have a device that isn't safety rated. You're going to eventually have a problem and maybe a time bomb, whether it's something that's listed in the standard or it's not, or whether you're required to do it. It all comes back to, do you want to see somebody get hurt based off of that failure? Or if somebody does get hurt and it comes back that, hey, because this is an older machine, they try to think that machines are grandfathered in previous standards. It's the end user's responsibility to make sure the machines are updated to the current standards and guidelines and providing the proper protection for people. So in the case where you have an old rope pull used as an emergency stop device and it has slack in the cable, well, over time, it's like anything else. Things can wear, they can deteriorate, they can rub. And you pull that cable when you really need an emergency stop situation, and that cable breaks and nothing gets triggered and somebody gets hurt as a result and they can't stop the machine, you're going to have some problems. The other aspect to it, when you look at, because of things such as age and wear, you got to do your checks on that, and that's one of the common things that happens.
Well, very good, and thank you, Mike. Well, I'm afraid we're out of time, and I'd like to thank Mike DeRosier for an outstanding presentation And we'd also like to thank Schmersal USA for making today's webinar possible. On behalf of New Equipment Digest, Machine Design, and EHS Today, we thank you for attending, and we hope you have a productive remainder of the day.